Hi everyone, my name is Paul. I'm a researcher at University College London, and today I will talk about our paper named SpeckleViz, a web-based interactive activity network diagram for AEC. Here's a slide about the contents. First, I will go through an introduction and context, then I will present some related works in visualizing design processes in AEC. I will then do a brief introduction to Speckle, which is an open source data platform for AEC. Then I will present finally the SpeckleViz interface and explain you the technological framework as well as its visualization and interaction features. Then I will talk about a case study that we conducted during SimAUD 2018. It was a Speckle workshop, and I will go through the case study brief and setup as well as data collection and analysis. And finally, I will end up with a discussion and conclusion section. In terms of introduction and context, so current architectural design and construction projects tend to tackle larger scales and become more complex. The multiple involved disciplines in the AEC sector often need to work globally from different remote locations. This increased complexity impacts the digital design up until the fabrication workflows, which are more discontinuous and challenging. Each industry partner involved in the construction of a given project operates on different software environments and needs to access the precise fabrication data of specific design components, and consequently managing and keeping track of design changes and data flow throughout the whole design process still remains a challenging task. So it is not enough to be able to model complex geometry, but the design process must also be created, shared, and understood in more simple, transparent, and intuitive ways. This paper therefore discusses how this particular challenge can be tackled through the development of a web-based interactive activity network diagram and named SpeckleViz that continuously maps the data transfers of the design building processes operated via the Speckle platform, enabling the end user to explore, interact, and get a better understanding of the constantly evolving digital design workflows. Some related works, this is from Front Inc., consultancy practice, which was involved in the rationalization of the intricate facade of the Morpheus Hotel, which was designed by Zaha Hadid Architect in 2015. So you can see here the project flow, which is basically an alternation between different Rhino sessions where this data is stored and Grasshopper sessions where the data is generated. More recently, this is the metagraph from Woods-Bagot in 2017, which maps the different data exchange between different Grasshopper and Dynamo files. Speckle is an open source data platform for AEC, and this is what we use in this paper to develop the visualization interface that I will talk about later. So Speckle is an open source data platform for AEC, and it was initiated by Dimitri Stefanescu at UCL in 2015 in the context of the European Research and Training Network, InnoChain. It has evolved quite a bit since, and there are many different contributors based in different companies. Basically, Speckle tries to link different software platforms which are usually isolated and gather the data within the same server. In terms of technological stack, Speckle is mostly a REST API, and from which you can build some web applications and application integrations for CAD software. You can also build more automation and scripts and other hacks. In the backend, for the database, it uses MongoDB right now, and there is also an authentication layer allowing you to have your own accounts, logins, and passwords. This is the Speckle's work breakdown structure. The higher organization level is a project. Inside the project, you have different streams. Inside the streams, you have different layers, and inside each layer, you can have different geometrical objects. Now imagine that you have two different users, user A that uses Rhino and Grasshopper, user B, which is within, who is using Dynamo. User A would create stream A and give read and write access to user B. User B receives stream A. User B creates stream C and gives read and write access to user A. User A receives stream C. So it's a very simple workflow, but this is the mechanism of how it works in Speckle. Speckle has clients, which allows you to track data connectivity and dependencies, who sends data what data from where and to whom. From the SpeckleAdmin interface, it is possible to access the source and receiver clients of each stream. So subsequently, a map of the project's information flow can be retrieved. So on a larger scale, one can imagine that we can represent all the different actors and all these different software that are used. So in a speculative or placeholder workflow, you can imagine you have different architecture models. Those are streamed to a more beam model, which then feed a structural analysis model, and this one will feed back the beam model and so on. So here's how the current SpeckleViz interface looks like. It is built within the SpeckleAdmin web app, and in terms of frameworks, we used Vue.js, Beautify.js, and D3.js for data visualization. Here's an overview. On the top, you have more like the controls. There are toolbars, time range selector, time range slider, tag query selector, and on the bottom you have the graph canvas itself, where the graph is represented. There is a color code, so if edges and nodes are more gray, it means it's older stuff, like objects were created a long time ago, and if it's blue, this is where the newest streams or objects have been created. There are clusters inside the graph, so the pink cluster represents the documents. Here, the grasshopper emoji is for grasshopper, obviously, and I used some satellite antennas emojis for receivers and a rocket for sender. And the blue clusters I used for people. PP is for Paul Poinet, those are my initials, and I work from UCL, and I generated here 5 different senders and 5 different receivers and 3 different senders. You can switch between different data flows, so the data flow per document or per user. You can zoom and pan the graph, so it's kind of gives to the end user more flexibility. You can expand and collapse clusters, which sometimes gives more clarity and visibility for the graph, because sometimes it might be very intricate. You can always right-click on the stream and view it in the viewer. You can always inspect with a time frame selector your graph. So if the nodes and edges are outside this time range, they will be fade out. You can query the streams by tags. In Speckle, you can give tags to each stream. So here you can query them, and if the stream contains one or more tags, they will be highlighted. And on the top right, there is a dedicated button with which you can actually view the highlighted stream in the viewer app. This is more like work in progress, but it just shows you that you can also query not only by tags, but by many different properties that are available via the Speckle API, which is also a nice way to select and inspect the graph itself. This was a very overview in terms of documentation, but you can read more in depth all the features by clicking on this link. The authors, for the case study, the authors have leveraged an existing digital workflow deployed during a workshop conducted at TU Delft in June 2018 in the context of the SimAUD conference. The streams created and used during this workshop have been reorganized through the Speckle project admin webpage, serving here as initial data sets to test and deploy the SpeckleViz graph. So in terms of brief and setup, after an initial introduction to the Speckle platform, we actually deployed a grasshopper workflow, which was actually segregated into different pipelines that all depending on each other. It was a very speculative workflows for freeform timber structure. So you had a global network control, and from that you could do some geometrical optimization and further geometrical generation and so on. So each participant had control over his or her own design space, and when satisfied with the local design outcome, the workshop participant could communicate the output of his or her own computational pipeline to the next design actor. So here's an illustrated overview of this whole workflow, and here are the different steps that I enumerated in the previous slides. Here's a video illustrating this. So you can see the graph is situated at the bottom of the project page. Here I can filter the graph with a time range, as I described earlier. Then after that, you can query one particular stream, view it in the viewer. So this was actually generated in Grasshopper, but you can use the viewer to inspect it more in detail. And then you can go back to the graph, go back to the next stream that has been generated, inspect it as well, and reiterate this process so that you can view each object that was sent over the platform during the design process. Here the network was projected on the surface, ensure the different freeform timber elements have been modeled. You can always inspect an object. And yeah, you can just repeat this until you reach the final level of resolution, which in this case are the single wooden lamella for each node. So this case study allowed to share design ideas across participants. It also enabled the monitoring of the stream design history and keeping track of the project timeline history. This paper introduced the current challenges in collaborative design workflows within the AEC sector and described the SpeckleViz interface, an experimental and work-in-progress web-based interface visualization tool which aims at representing the activity network that operates within the open source Speckle framework. In terms of limitation, of course, it uses Speckle, which is an open source initiative, so there is a lot of maintenance required to keep updated the client's integration. SpeckleViz only is used as a visualization tool so far, so we are thinking of transforming this interface into a more data management interface. And we also think of visualizing data flows across multiple projects and not within only one single project, which is the case until now. So yeah, that's it for me. Thank you very much for joining in today and listening until the end. Bye.